good evening to all the people here on this online session. This session is going to be of two halves. One is I'll be talking about Risc-V, followed by Dr. Anthony, who will be talking about AI and its applications. So, just quickly, 7 minutes of your time. So, Risc-V is nothing but it is a processor similar to your ARM controller available, but no, we are calling it ARM is also a RISC-V, but RISC-V is basically an open source instruction set architecture which is used to develop custom processors for a variety of applications from embedded designs to supercomputers. So my topic for today is on RISC-V, and let me try to convince you why RISC-V and role of RISC-V for space applications. So during our studies, we could gather a lot of information from the internet, and we could find out that there is a lot of traction towards RISC-V for space applications. I've just taken snapshots of all the literature that which interested us. Why we need to get into RISC-V for space and defense applications. So NASA is actually trying to see whether they can use RISC-V processor for all their high performance computing, or we simply call it as high performance space computing. Similarly, European Space Agency has also done a lot of workshop educating people on creating an awareness on the importance of RISC-V for space application. Similarly, a lot of universities in Netherlands actually have prepared a roadmap how RISC-V can be leveraged into space applications. So, by considering all these factors, we also thought from our country, particularly from our campus, why don't we also get into RISC-V and try to build a complete ecosystem within the country, which could also drive some of the applications regarding to space requirements. So that is the crux of this entire topic, and I'll be able to tell you what are we actually trying to do, and why are we trying to do this, and what will be our end outcomes. So it's a very brief introduction. Why RISC-V? Is the RISC-V going to be the future? Yeah, we found that from the literature there is a lot of activities, lot of momentum created around RISC-V, particularly because you can customize the applications on RISC-V. We can customize the architecture of RISC-V, addressing the performance. The second important activity here is, yes, we can bring in lot of applications into RISC-V and make it more generic, and try to break down all the barriers which are required to develop a RISC-V based application. On the other side, some of the computer processors today monopolize the entire activity, so it becomes easy for us to adopt RISC-V. And since it's an open source, so we thought maybe we can also try to see how we can customize this RISC-V for space applications. So considering these three important trends, we thought let us also try to build a community at our campus driving RISC-V activities for space applications. So globally, it is found that again, there's a factor that tries to motivate us why we should get into RISC-V. So the RISC-V IP and software market itself is going to be almost $1.07 billion by 2025, and there will be at least 62.4 billion RISC-V CPU cores made available by 2025, and lot of industrial sector will consume RISC-V IP cores. It is particularly going to be used in cloud, data center, automotive, mobile and wireless applications, memory, consumer and IoT devices, and industrial IoT as well. And based upon the study, what we were able to understand is RISC-V is also going to play a crucial role both in aerospace and defense applications. So considering this, we it motivated us to get into the process of RISC-V. And the current trend in our country with regarding RISC-V is as follows. So Minister of Electronics and Information Technology, shortly called as METI, launched the Digital India Risc-Fi program to develop local microprocessors as part of Atma Nirbhar Bharat or Self-Reliant India. So it's a very big initiative by the government, and it was launched 2 years back. And the outcome of this RISC-V or DIRV, we simply call it as DIRV program, is IIT Madras, which is a premium institution in the country, was able to develop a processor called Shakti processor, again based upon RISC-V. And CDAC, another premium institution in the country, developed a processor called Vega processor. Currently, in our country, we have Shakti and Vega processor, which are all basically the RISC-V processor developed, and a lot of applications are actually being worked on it. Recently, last week, Government of India also launched a program called Digital India Future Labs. It is an entity which can network industry, academia, and all the startups. So there is a huge drive that is happening in the country to promote Shakti processor, Vega processor for all applications. Since we are from Bangalore, no, from the Karnataka state, government of Karnataka has also gone into this risk-fi community process, and there is an entity called Karnataka Digital Economy Mission (KEDAM), and their project by 2030 they should have at least 10,000 startups in digital economy process, generate 5,000 plus job opportunities, and 80,000 plus workforce for semiconductor industry. So considering the drive that is happening in the country and the drive happening in the Karnataka state, particularly in Bangalore, we thought that yes, we need to prepare a robust software ecosystem, hardware ecosystem that can drive risk-fi cores and solutions. So we have started off a new initiative called Community of Practice, shortly called as COPI, at our institution, Cambridge Institute of Technology, to drive the activities with regarding to risk-fi pertaining to space as well as all other applications. So the community of practice, it has a purpose, it has people involved in it, and there is a practice involved in it. So, as part of the COPI, which was recently inaugurated at our campus, and we had partnered with Thales, we have partnered with Synopsys, Samsung, and many other industries who are actively participating with us and helping us to drive this community of practice on RISC-V. So the primary objective of this community of practice is to build CPUs, IPs, products, and supporting softwares, and also develop a lot of innovative products that can be used for local needs, and develop a customized RISC-V core for multiple applications. So we have identified three phases of activities at COPI. One is seed. So we try to build communities, we build expertise, drive this community to develop a lot of applications, and then the business process. So we also try to see, okay, we generate revenue, or we try to have a self-sustainable model in this activity. So with these three important phases of activity, seed, drive, and growth, COPI is into risk-fi activity. So what is that we have done till date? Okay. So currently we are trying to work on encouraging students to get awareness about risk-fi. So that is where we talk about skill development. So almost 120 graduates have been trained in the last 4 months, and they have been imparted the knowledge of risk-fi. And we are offering currently internship to 1100 students on risk-fi. So these students will also be able to understand the importance of risk-fi, get the basic knowledge to start doing multiple projects, activities with regarding to risk-fi. And we are planning to conduct risk-fi hackathons across the country, and the requirement here is we need to have at least 1,50,000 students to be participating in this hackathon in the next 3 years. This program is completely supported by Government of India, and we are one of the partners for to Government of India in promoting this hackathon activity. At CIT, we have also developed a lot of products based upon RISC-V. Some of the products have been listed out over here, like lace defect detection system, sugarcane seed cutting machines, sanitary pad vending machines, and IoT enabled garbage collection vehicle for waste monitoring. So all these products, whatever you are able to see, are having the Risc-V processor inside it. Now you may be wondering, what is the Risc-V? Where did we get it? So uh, what are we actually trying to do is, okay, we are trying to right now build a nano satellite lab kit which could be deployed to all the schools, colleges, and other entities to teach the students on how do you use this Risc-V development kit build nano satellite project. So the specifications of this RISC-V chipset that is available from CDAC, that is called Vega processor, it has lot of features, lot of applications, lot of IPs, which could be an appropriate candidate for developing a lab kit for RISC, nanosecond activity. So we are actually right now in the process. And to conclude, so we are trying to right now skill around 1,000 graduates, postgraduates in Risc-V. We are also in the process of developing the Risc-V based lab kit for nanosatellite project. It could be a cost-effective and affordable kit that could be deployed in all the schools and colleges within the country, so that no, the Risc-V promotion also happens, and they also understand the importance of nanosatellite and develop technologies for nanosatellites. And we are also in the process of developing a Risc-V processor core with customization and develop a verification IP, FPGA implementation, and a chipset. So this with this I stop and hand it over to Kiran.